Hi, Sebastian. How are you? Hi, Martin. We will start in a bit. Yeah.
Oh yeah, that's fine.
Yeah.
Yeah, Sebastian
Okay.
said hi, but then we were only hearing the music.
Yeah,
I
yeah,
have
yeah.
to admit, I've never had such a professional introduction of myself. I really like it.
Yeah, we took somebody else's body for your head.
Yeah, you found the best picture you could find because I was like, whoa, damn, I'm even looking good there.
Yeah, yeah. So I think we will start. So I think the moderator will start the session, and then there's you in the screen.
Yeah,
Big
that's
one.
okay. That's okay.
Good afternoon, everyone. It's a pleasure to welcome you all to today's international joint class, Novel Research in Enterprise Architecture between Telkom University and the University of Twente. I'm Aaron James, and I'll be moderating for this session. But before we start, for everyone who participate, please turn on your camera. Before we proceed to the next agenda, let us first hear the opening remarks from Mr. Iqbal Yunisar Mukti. Mr. Iqbal, the time is yours.
Okay, so yeah. Hello, everyone. Hi, Martin.
Hi.
So hello, everyone. Coming to this session. So the session will be in addition to my reunion to Martin Koot, my best friend at the UT. So we will have online joint class in the topic of research in enterprise architecture. So in this session, you will hear how enterprise architecture, let's say, way of thinking actually applied to as a means to adopting novel technology innovation for addressing specific problems. And here, Martin will tell you how enterprise architecture modeling is used for improving a logistic process, the disturbance in logistics, right? And then I will share my research on how we use enterprise architecture modeling for creating a basis of smart rural reference architecture. Yeah. So hopefully this session will add a new perspective of you students to the enterprise architectures, because in course we learn how enterprise architecture is applied in a company, like creating artifacts following TOGAF that to some extent might be boring, but now we use the logic of enterprise architecture in a more creative way. So, and I believe Martin will present that in very nice way, because he recently just elected as the, what, Martin? Yeah, you can bring your trophy. The best teacher
hey,
at the University of Twente.
yeah, not the University of Twente, from the study program that I'm doing. So that's
You are
part
muted,
of the
by the way.
University of Twente.
I cannot hear you, Martin.
Oh, you don't hear me?
Oh, sorry, because I muted myself in the speaker.
Oh.
Okay, so I think that's my remark. So I will hand it off to the moderator.
Okay, thank you, Mr. Iqbal, for the opening remarks, which we appreciate your time and valuable thoughts shared with us today. So let us proceed to the main agenda of today with a presentation by our first speaker, Mr. Dr. Martin Koot. Before we begin, allow me to introduce our speaker this afternoon. Dr. Martin Koot is a lecturer of Industrial Engineering and Business Information System, University of Twente, the Netherlands. He holds both BSc and MSc degree in Industrial Engineering and Management and completed his PhD in Condition-Based Logistics at the University of Twente in 2024. His current research aims to make supply chains more resilient by using various Internet of Things solutions to quickly detect and resolve disruptions. Besides his research activities, Martin also supports various BSc and MSc courses related to research methodology, data science, and academic skills. So, without further ado, let us welcome our first speaker. Good afternoon, Dr. Martin Koot.
Good
How are you
afternoon.
today?
Yeah, good. It's always funny to get in contact with Iqbal and all his colleagues and friends because you say good afternoon, but I just woke up. It's it's 9 o'clock in the morning here, so I'm like, oh man, I definitely need my coffee. But it's good to be here, and it's also good to see so many students who are enthusiastic about making enterprise architectures. And what I hope that I will do. Sorry, maybe I should do the small talk first. How are you? Sorry.
Okay, I'm glad to hear that. I hope you and everyone here are doing well. Now, let us begin to the main presentation of today's agenda. Dr. Martin Koot, the time is yours.
Perfect. Hey, good morning, everyone. I will share my slide that I had in mind. It's on my other screen. So I will try to look in my camera a few times to get in contact with you, of course. But when I'm looking away, that's because I have my slides there. So let's see if that works. Just a sec. And there we go. Hopefully you see the slides, right? Maybe somebody
we can see that.
Yeah? Okay, no, perfect. Because I have to admit, when I was listening to your introduction, Aaron, I was like, whoa, I do quite a lot of research on a variety of topics, but I always consider myself a professional hobbyist. Iqbal and I were lucky that we were guided in our PhD research by the same promoter, Maria Jacob, and she was really the expert on enterprise architectures. And she always got us inspired to, with the question, okay, you have companies on the one hand where you have processes, but all those companies have to rely in this digital age on information systems and technology, and how to integrate those, how to see that on the one hand we have business processes running, and how can we improve those by using all the IT advancements that we have at our today's world. So that challenge, that is what I was always captured by. And in this lecture, I will show you actually a little part of my PhD research where enterprise architecture modeling was applied. But my main aim is not to explain how to make such a model. You know that. You're following the courses. You've probably seen Iqbal talking about similar topics already. My main aim is twofold. First, I want to show you that you can... The benefit of our enterprise architecture modeling is that you can model whatever you want. So I will show that. I will show you an enterprise architecture of how current logistics is actually making their planning. And then I will show you how I want to change that. And that is a benefit. You can model whatever you prefer. So that is the first benefit. The second aim that I have is that making a model is easy. Just drag and drop with a few blocks and make some arrows, but how to sell it to others, how to make sure that people are convinced, like, yeah, this is a good way forward. We are going to implement the system you have made. That is where I will give you a few hands-on tips and tricks for that. And therefore we use the Book Lab tool. I just shared that in the comments of this lecture. If you go to wooclap.com and just type in Telkom, then you will at some point enter the interactive lecture slides that I have, where I will need your response, because we are going to review an enterprise architecture that I've made myself. So you can be very critical. I really prefer that. And if I'm going too fast, or if you have questions in the meantime, just raise your hand and feel free to get questions. Okay, but that's roughly the setup. So if that is clear, then I guess that I can just continue, right? So let's start. So as you already hear and see from my lecture, my research is on logistics and how can we make it smarter. So what does that mean? We have a lot of equipment running through the world. So if I go to the, so here we have a map, for example, from all the, it's a heat map of the European continent and a little part of Asia and the northern part of Africa. And you see actually all the transport lines that marine vessels take across our oceans. And the redder an area, the more traffic there is. The more ships that are going there with containers or bulk goods like oil, gas, sand, whatever they are transporting. And maybe some of you already might expect what I will discuss, because in 2021, if I'm correct, there was a big disruption here, and that was somewhere near the Suez Canal. So you see that all the ships coming from your part of the world, from Asia, I will, by the way, get my pointer running. So here I have a laser pointer. So you're not on the map, you're somewhere on the right. But when I'm here in the Netherlands, on the top left corner, actually a little bit on the very close to the border with Germany. And if I order something from, let's say, India, China, Indonesia, it has to be transported here via the Indian Ocean, goes into the Red Sea, has to transfer via the Suez Canal, and then it goes via the Mediterranean to the port of Rotterdam, and then I, in the end, get my goods that I've ordered. But in 2021, there was a very big disruption. The Ever Given was blocking the Suez Canal, as a result that all ships that had to transfer this canal, and that is roughly 20-30% of the global trade volume, so that's quite a lot of ships, they had to wait. With a lot of negative consequences, like people were starting seeing their product delayed. I bought my house at that same time, maybe Iqbal remembers. So I ordered a lot of garden equipment, like chairs, banks, tables, and I constantly got a message on my phone, your delivery is delayed by a week. You might expect it in 7 days. And then 7 days later, your delivery is delayed by another week. Why was that? Because those ships couldn't get through the Suez Canal. So what is the impact of such a disruption? That is the focus of my research. We have a planning made, we have the logistics scheduled, so our ship is ordered, the container is loaded, it's going from one port to another, and we can keep track of all those ships going around the world, and then suddenly something unexpected happens. And then what are the impacts on that? Delays, waiting time, ships are building up, there's a queue created around the Suez Canal. But also when the Suez Canal was released again, so the problem was resolved, all those ships were actually coming in Rotterdam and with enormous amounts. And then they suddenly had to stay in the queue there as well. But what happened? So here on the left you see a map of the port of Rotterdam. You see all the ships coming in and coming by. When the Suez Canal was blocked, in the meantime they built a digital dashboard where they could keep track where all the ships on the globe are. Just to see, okay, now these ships from the port of from the Suez Canal are approaching Rotterdam. So they are lining up here in the front of the port gate. And when you know where they are, you can actually schedule your equipment better. So when you know at that time a very big ship is coming and needs to unload 50% of its containers, then you can already estimate how long will those cranes on the port actually need to unload those containers. And during, so take a good moment here to reflect what happened during that. This all happened. They built the dashboard when the Suez Canal was blocked. So there was no time to implement additional IT anymore. The ships were already lying there. There was no time to build information systems from scratch because the information needs to be there. The ships were waiting. The port of Rotterdam was already panicking, like, uh-oh, there is so many work coming our way. Now we have nothing to do. But when the Suez Canal is released again, we are screwed. That was a little bit the reasoning. So in order to prepare ourselves, build a dashboard with all the locations of all those ships. And they built it, so that they could better schedule their operations. So that is a little bit the story that I would like to make. The data was already there. The ships were already on their way. There was no information system designed that could actually rely on the current position of those ships. But when there was a need for it, because suddenly there was a disruption and everybody was panicking like, oh no, I need to know when all those ships are arriving. So when the need was there, they built the system. And that is what the article on the right of my screen tries to say. So with that system, they could perform their operations in a more flexible way, because when they knew where the ships were, when they had a transparent overview of what is the workload and when could we expect it, they could better decide, maybe do this ship earlier and that ship later. So for the operator, it's better because they become flexible. But also for the customer, for me, it was also better because I could actually track where my tables were by using that tool. And I got a very good estimation of, your ship is scheduled in 2 days. So it takes 1 day to unload the container, that it needs to be transformed into a truck, needs to drive from Rotterdam to Enschede. That is also a 200-kilometer drive. So I knew already I can expect my delivery in 5 days. And the company that said that I ordered my product with still said, we don't know, probably a week. So also for the customer, such a tool is handy because you can get reliable estimates of when you might expect your order. So that is a little bit the problem. So in this, I hope that you see the context. What can we do with all the data that we gather in today's environment and how to make a better system out of that? I will discuss with you how to make such a system because that was my research. How to make such a digital dashboard or planning tool that can anticipate on those type of disruptions like the Suez Canal in a more resilient way. And I will do that in 5 blocks. So I will first give you some models explaining the problem in a little bit more detail as I just did, but then with supportive theory. Then I will move forward with the requirement analysis. So, okay, now we know the problem. Disruptions may occur in logistics, how to anticipate on that. Then what do we need then? That is discussed in the second part, the requirement analysis. And then we start modeling. So the enterprise architectures are coming up in the block 3, where we first start how they are currently scheduling logistics. So that is the as-is architecture. And then once we know what can be improved there, we will move forward with the to-be architecture. So what do we want instead? So this is a translation of the requirements in point 2 into an enterprise architecture we want. And then finally, if I have time left over, because I'm always running out of time, so Iqbal and Aaron, please correct me if I'm taking too much of your time, then I just have to let me know. I'm fine with that. But if I have time left over, I will discuss some further research, what those insights from the enterprise architectures that we have made brought us, and where I'm actually working on right now. Okay? Okay.
Yeah, please use your phone.
Yeah, okay. Now, and I need your help. I already said that. That's what I also said in the book lab tool. So you might expect some questions from me to you, the audience. So everybody can be involved because I will use an interactive tool, the book lab tool, and that is actually in that 3rd part. So there I will ask you to create the architectures that I've made, and I will also do that for the to-be architectures in the 4th section. So now you can still relax, but know that somewhere halfway the presentation, I will ask you for input. Okay? So let's go. So my actual research, coming back to the question that we had in the previous slides, is we have a lot of equipment running around the globe that are actually transporting the goods we need. Trucks, on the road, but ships on the seas and the lakes and the rivers. Airplanes are going through the sky. the trains, bicycles, little vans, whatever you have. There are goods transported by means of containers. There is equipment needed. And the idea is, how can we make better planning in cases of disruptions? And as you saw in the Port of Rotterdam example with the Suez Canal blockage, it starts with data gathering. So my actual research is, what can we do better in terms of planning, similar like the Port of Rotterdam example, if we equip all those physical hardware, the trucks, the containers, the goods, the pallets, the cranes, the airplanes, all that type of stuff, if we deploy those with sensors and data gathering devices or tracking devices, so that we can get a better overview where is the equipment actually in the globe and how does it relate to its process, where is it on track, as you could say, can we then make better decisions? That is the key questions that I have. So how can we use that idea of deploying physical equipment with sensor devices? That is what we call the Internet of Things. So we make things smart and interconnect them, the Internet of Things. How can we use that for our advantage to make logistics better? How to be prepared for disruptions? And if we take a look into theory, we see a lot of work already on that topic. So here I have two examples. On the left you see a model from Ding, Jin and Li and Feng, where they say, where they take a look on the business perspective. So we have logistics, and we need to make it smart. How to make that happen? And if you then take a look, you see that they have some thought there already. So it's not me telling you how to do it. Others have found the trick already. So if you want to have smart logistics, you need a few things. You need the IoT to gather the data. So on top you see the Internet of Things, so those sensors that we were talking about. And once we collect the data, we store that. We have a lot of data, big data, and we host that via cloud services to do our computational workload. Then in the end, we can support our decision making by the insights we derive from those computational resources. So that is a little bit the idea. So the IoT provides us the data, and once we apply computing, like standard database querying or data science, machine learning, and nowadays also artificial intelligence, AI, if we apply that on the data that we just gathered, we can support better decisions. But then still, how? How exactly? So this is like the big overview. I know it sounds reasonable, more data analytics, better insights, better decisions. But how exactly? That is not helping us much right now. We only know the raw ingredients. We are still missing the recipe. Iqbal always made rendang here when he was in the Netherlands. Not always, but he cooked it quite some time. So your wife maybe did that actually. I don't know who made it. So now I know that there is beef in that and some spices, but we don't know how to make beef rendang still. So how to do that? So let's take a look at a model that comes from computer scientists. That is what is depicted on the right. They are explaining a little bit in more detail how to approach further. So instead of saying you need IoT for better decision making, they say start on the bottom. That is where you have your sensors, where the data is actually gathered. RF radio frequency identification tags or just sensors, Bluetooth devices, embedded sensors, a thermometer measuring the room temperature, for example, either connected hardwired or via wireless connection. And when you have all the data gathered and make that available via cloud network, so in the network layer you make sure that the data can be shared among different nodes in your computational architecture, then you once you have it shared, you can ask yourself, where should we deploy the data? So which services should it support? So that in the end you can use the analytical insights from those data obtained by those devices to the applications you need. So that is on top, you see the interface layer. That is where it has connection with you, the user, the businesses. Where do you want to use the data for? So this is roughly helping us understanding how is the data from the source, the sensors, going to its final place, the user or the applications. But then still, how to anticipate on those disturbances. So now we know where the data is going to, but we still don't know how to make a better planning then. So that is still the question that we were facing. And therefore we moved forward with actually our literature search, and Iqbal will show you, I believe, after my talk, how to conduct a literature search on this topic. I did something similar, and I was only able to find one model helping me a little bit further. So here you see an enterprise architecture model. I hope you recognize that at this point of your course. In yellow, the processes, in blue, the applications, and in green, we have the IT components, the hardware. And if we look, okay, how to include disruptions into our business processes, that is what this model is saying. An enterprise architecture perspective on making smart logistics. So the title of this paper really fits the bill of my research, but then we see we need a software package that can that can handle disruptions. So then again, how then? What does that software need to do? I don't know. Which logic should be in there? How to connect those sources still with the processes, and when the disruption is occurring, how do you detect it? How to anticipate? What actions do I need? That we still don't know. And that is my research that I investigated. We want to actually explain in more detail what is happening in such a software component called disruption handling. So that's it. So I hope that you understand a little bit my reasoning better now. What do I want? I want to make use of intelligent systems, I want to make logistics smart by relying on the Internet of Things, so that we deploy more data gathering devices in the field, so that once we see that a disruption occurs, we can make better decisions. So how to translate it into a good model? That is what we will start doing first with the requirement analysis. So if we have to distillate all those visuals with the trucks going from A to B in a more plain setting, then there are actually two parties that are key in our story. The customer who orders the products or sends the products away, that could also be the manufacturer, for example, and the party who does the logistics for us, the logistics operator, like the vessel, the truck, the airplane. These are the two most important, I would say. There are more stakeholders. There are also companies taking care of all the different modes of transportations that we have. I will just, for the sake of simplicity, keep these out of the question. We are simply asking ourselves, who orders the transport and who needs it to deliver? That is the customer and the logistics operator. And the customer wants what they ask for, so they need some quality products and services, but they also want to have it in a reliable way. If I order it and I expect it in a week, then I also expect it in a week and not a month later. So customers want reliable services, but also the quality they expect. While on the other hand, the logistics operator, they need to deliver the product as expected by the customer, so also for them quality is a thing. But they have to be aware of all the uncertainty and changes in the real world, like the Suez Canal blockage, or queues in the port, or a ship that breaks down. So they also want to remain flexible. So a plan is good, but when the world changes, when disruptions occur, they want to adapt. So flexibility is the thing. So in this way of modeling, you can see what drives the stakeholders and which goals are supporting those drivers. Because if you want to be flexible, you need to increase your responsiveness to disruptions and reduce operational risk. This morning I was running very late because I needed to bring my son to my father-in-law. And I was exactly on time, actually already a little bit late. But if there was a traffic jam on my way to the university, I would have been late. So there was a high risk that if something went wrong, I would be late for today's tutorial. So that is what is said here. So if you want to become more flexible, a good way for it is to reduce operational risks first. So to reduce the impact that those disruptions might have. Yeah, that is what we try to do for all these drivers. Just another example. If you want to be more reliable, then you need to deliver. That means that you need to deliver your products on time, but also get a notification when something happens that you didn't expect. Then you still might get your products delayed, but if the customer is informed, maybe then you're still reliable. So that when we know what we want, we can think, okay, how do we make that happen? So then we think in terms of outcomes. So now we are looking ahead of our research. So assume that we are done. What can the system that we are going to design do? In our case, we should be ready for events. Disruption might occur, so we should prepare. We don't know what will happen, but that is the challenge. What can happen? Prepare for the unknown. Once something happens, you have to be ready to give a response. So that you have the models already there. We see that there is a delay. Run the algorithms, make the planning different, and go another way. Maybe don't go through the Suez Canal or go sail around Africa, for example. And once the response is there to take the worst damage under control, we have to recover the system to the predefined settings again. Because a disruption is always getting performance deteriorations, performance will go down, but then we have to restore it to the levels we want. So that is in the end, in order to remain reliable, we have to restore as quickly as possible. So that sounds still vague. So even there you can have sub-outcomes. I will not discuss that in detail, but I hope that you see the main line of my story here. By the way, Iqbal, I will upload my slides to you so that you can share the slides afterwards with the students so that you can look into those modules in more detail. But the rough idea is, in order to be ready, you need to either predict or detect the disturbances. So what is happening? You need those IoT devices for that, the sensors. Then you have to check, is the disturbances really a big thing? And when it is, reschedule. If it's a minor thing, just reschedule and continue as planned. But if there is a really big disturbance that has a definitely impact on the customer's reliability, then you should maybe re-inform and look for a bigger re-optimization challenge, because it's not only one truck that is impacted, but maybe more. And then you need to recover the whole system. So once we know roughly what we want, then we can ask ourselves, what is going to make us design move forward? So which principles do we use to build our designs on? Because that is the beauty of our field, our line of research. We are engineers and we can engineer whatever we want. So you have to make clear, in order to convince others, how are you making your designs? Which view, which perspective, which principles do you use to make the system you have in your mind? What is the engineering inside you telling you this is the perfect system? Because that is what you try to deploy with those principles. And in our case, we want to make logistics smart. That really fits aligns with that principle of Industry 4.0 developments. So that we are not only making logistics smart, but also our factories, our houses. On my phone, I can open my fridge at home. So I have a smart device at my home. That's also an example of that Industry 4.0 principle. And we will use these 6 criteria to build our enterprise architectures on. So I will quickly walk through them. So real-time capability means I want to get a real-time, up-to-date insight into the system's status. So this is the data that you need to gather on the spot. If I want to know where my truck is now, I need to open my device and see where it is exactly, not where it was a few days before. When you have the data, you have to make sure that it's interoperable. So it's now at the sensor, but it has to be transported in a cloud setting to other computational nodes in our network. With virtualization, it means you can actually do simulations with it. So now we know the current way of operating. But can we do it different? So can we make a digital copy of the actual system to run simulations with to see if we can do it better without changing the system before we... so experiment, that is key. Decentralization, if we can make the equipment smart itself, it saves us a lot of work. So instead of making all the decisions central, a human planner, for example, can we make the decisions, can we let the objects that make the decisions themselves? Modularity, can we expand easily? So now we have one truck, one device. Is our system still working with 100 trucks, 100 vessels, other air modes of transportation? And finally, service orientation. So it should be easily, that's also a little bit connected with that modularity. So it should be very clear what our system is providing, so that others who might think like, hey, that is interesting, I also want to get access to that they actually only have to rely on an API to get access to all the computational logic in the software that we provide. So that is a little bit it. So that is all the necessary evil to start modeling. Maybe it's still fake. Maybe you still have questions like, how did you, what did you want exactly? So take a look at those architectures when you, after the lecture by looking into the slides. But now it's time to model. So before we actually show what we want, because that is what we did, this is the requirement analysis, this is what we want. It's a good starting point to see what is already there, because we don't have to reinvent everything again. In the Port of Rotterdam example, we saw already that a dashboard could be made without implementing another IoT device anymore. The ships were there, they were in the Suez Canal. We couldn't go there, but still we were able to extract their location in real time and provide it on the dashboard without any hardware investments. So there's a lot that we can reuse. So what is the current architecture that is in place, but in logistics in general, what is our starting point? Let's model that. And that is roughly this. So most logistics companies are working in this like of manner. They have a big room where you see a lot of screens with a lot of data points, small monitors, but also very big monitors. And then you see a human operator staring at the screen, waiting for disruptions to happen. And that's it. They wait. They don't know if it will go good today, but then suddenly something happens. Oh no, a traffic jam. Oh no, a ship is capsized. All the containers are lost. What do we need to do? So they are waiting for disruptions to occur. And once the disruption is there, then they start asking themselves, whoops, what should we do now? And in my opinion, that is too late. Then you're actually only doing damage control. But that is what is currently the way of rescheduling. Relying on information systems to support the decision maker to reschedule. That is roughly it. So if we model that in an enterprise architecture, we are roughly getting this. So here you see what I just said. There is a dynamic event on the left. So something you don't want, something that is unexpected. Then you can either observe that. So you observe that the disturbance is there. And then you have two decisions. You continue as scheduled, like, yeah, shit happens. Let's continue. Or you take that into account and reschedule operations, but that is done manually. That is what you see here. So the fleet coordinator is looking for the disruptions to occur, and then the operator also decides: am I going to reschedule? Do I handle the disruption, or can I let it be? Can I just say, okay, a little bit worse than initially scheduled, but still feasible. So let's continue. A better approach, what they are already doing, is that they are not only observing those systems, they are not only waiting for disruptions to occur, they are also running machine learning algorithms to predict those disturbances. So that is already a good habit, that when you see piling up a lot of ships before a particular port, they already have some good models in place to predict, maybe we have a problem in a few days. But that is roughly it. So they already have some smart technologies implemented to predict if there is a disturbance coming, but they still have to rely on human intelligence, because when the disruption really is there, the human operator is still watching to the screen, what should I do now? And is that what we want? I don't know, but I'm just saying how it is done currently. And they use, as you saw in that image, they already have some information systems in place there. So there's always a fleet management system that gets access to all the telematics of the fleet deployed. So where is it? What is the GPS location? What is the status? Is it driving? At which speed? Who is driving? All that type of information. It's also combined with legacy systems from the company. For example, I ordered something. There is a product in a container that is transported. So that type of information is often in enterprise resource planning system on the company level. And if you combine that with the fleet telematics system, so if you combine the ERP system with the fleet telematics, you have all the information you need to schedule your fleet in the fleet management system. But as I said, Most companies are very advanced already in their IT support, so they don't rely only on the digital equipment, on the physical equipment itself, the trucks, the cranes, the containers. They store that in the cloud nowadays. So they send they wirelessly send the data they have gathered to a computational node somewhere on Earth. Somewhere there is a data center, maybe in the company or by one of those big tech companies like Google or Amazon or Alibaba. And there they have all the data stored so that they can search for more patterns there and do the predictions that we were talking about earlier here. So those predictions are actually based on all the data stored in those data centers. And that is roughly it. So if I explain how do they schedule now, this is it. Some companies are running ahead. They have maybe more advanced technologies. Maybe smaller companies don't even have that big data model yet. But on average, this is what you might expect in a standard logistics company nowadays. And then we ask, how smart is that? So if we take those criteria again, so here we have those design principles once more, then we can ask ourselves, is this the good way forward? Is this a really smart approach? And that is my question to you. So instead of explaining you how I grade it, can you do that for me? So this is the time to go to that Wooklab tool. So either press in the chat in the URL, go to the wooklab.com and type in the event code, Telkom, or simply scan the QR code. Then I can in the meantime take a sip of coffee.
So please students be actively involved, right, in this.
Yeah, I already see 11 people enrolling, so that is good.
Yeah.
We have 62, so we still have some to go. But it is a start.
By the way, Martin, actually, I have shared your paper in the conference. I mean, okay. on this matter, and I have also asked them to read the paper and make some sort of, let's say, summary of your works. So I think, I think this should be an honor for the students.
Perfect.
To meet the author himself.
Yeah. And I'm always open to, if you have questions, let me know, because in that paper I still have some issues that I'm ashamed of myself. There is actually no evaluation in the paper. I did it later, but I will discuss this in this lecture.
Actually, your paper, I always use your paper as the example in my lecture. So I'm also teaching research methodology, and I always use your paper.
Oh,
and
that's
also,
a very big honor. No, thank you.
Also, also Maria's, Yifei. But in particular, your paper, I always use that, and I emphasize.
I do it always the other way around with yours. For students that are graduating, they always struggle here with how should I implement that? And then I always say, I have an example of a PhD student who actually not only said, this is what I'm going to make, he built it. So you can go search online and you will find his work. So I do it the same, but then for the later stage. So, hey, let's continue. If you didn't scan the QR code, doesn't matter, because you can still enroll in the tool later on by simply just using the URL. So here we have roughly again, literally, we have exactly the same criteria again. So those 6 design principles coming from Industry 4.0. And I want you to grade all those 6. And I want you to grade the architecture as it is. That is depicted on the right of the screen. And grade it by means of a 5-point Likert scale. So if you think, just for the sake of example, is this way of working capable to gather data in real time? If you think so, give it a 5. Then you say, I extremely think that this is very suitable for gathering data in real time. But if you think like, no, this is the worst of the worst that you can have, then you press a 1. So 1 means I completely disagree that this criteria is met by the architecture. And a 5 means I completely agree. that this architecture meets these particular criteria. And 3 is in the middle, that you either don't know or are unsure or don't care. So if you would like to give your responses here and try to do that for all those criteria, and if you have questions, maybe use the chat or unmute yourself, then I can help you maybe. But let's reserve 1 minute for that, okay? So that we can, so that we have some input to work with. And by the way, be critical. I'm the lecturer and I made this, I know, but I'm honestly looking for your opinion. Do you think that this way of this process is helping you to gather data in real time? If you think so, then give it a 4 or 5. But if you honestly have doubts, then maybe it's better to give a 1 or a 2. That's exactly what I'm looking for. Still 30 seconds. So for the people who didn't submit anything yet, just try to rely on your gut feeling. You listen to my story, you see the model, try to interpret those criteria. What does your gut feeling say? And just give a response for the sake of having a discussion. It's you are all quite happy on average, I would say. So if I interpret roughly what is depicted here, on average, I would say you score a 4 out of 5. So that means you are satisfied with for most criteria by using the current way of working, and that makes sense because this is what companies use in the real world. They schedule their operations and they do that, so it's a good way for it. But can we do it better? That is the question. Where can we still improve this current way of working? Can we find improvements in the current model? So that is what I'm going to ask you next. If I put you in charge, so here we have the same model again, where would you like to change? On your device, you can probably pick somewhere on the screen the thing you want to change. So let me know. What would you like to change yourself? And there's no good or wrong. We are engineers. If you want something, you can do it. So what would you like to change? If you would like to submit that for me, then let's see. Oh, I see no responses yet. Or is there nothing you want to change? That could also be.
Or perhaps we use the same link, right? With the previous one. Or perhaps they're waiting for the link.
No, probably. Maybe it doesn't work. It could be. I can check it real quick on my own device. Let's see. Hey, yeah, there is one. So it should work. Yes.
Yeah.
That student gets an automatic pass for the remainder of the course. No. I'm not in charge there. But okay, no, so it works. Then I don't have to check that. For this, I'm looking at the time. I see that I'm already running behind. If you ask me, so this exercise, try to do that on your own. If you have some submission already, but and maybe you forgot to submit, press send. Then we have that in the slides, and I can share that with you afterwards. But if you ask me, I would say the human involvement. So on top of the slide, so on top you see that all the rescheduling is done manually. They use the big data tool. The data mining is only used for prediction of events, and if there is something predicted or either observed, human operators have to do all the work. They have to reschedule, they have to find alternatives, they have to do the calling, they have to inform the customer. So there's a lot of work there, and I want to get rid of that. And that is partly already in that fleet management system. So now it's mainly a point of consumption. They see this system, they look at the fleet management system to see the current way of working and all the performances. So it's mainly a tool for descriptive analytics and that maybe diagnostic analytics. But I want to transform that actually in something they can use for prescriptive analytics. So they're not only saying this is how it is now, but this is how you can do it better. And therefore, we are going to see if we can deploy more sensor devices on the physical hardware. So those IoT devices that are already there, can we maybe extend that with more data gathering devices? That is a little bit my perspective on the issue. So here I say the same. So how smart is the as-is situation? I would say it's already quite capable in gathering real-time data and sharing that in between nodes, because we can see where the fleet is already in nowadays companies. But how to virtualize that, how to make a digital copy and see if we can do it differently. So that one is still open for discussion. That could maybe be done better. And also that decentralized decision making, can we let the vehicles themselves make the decisions instead of the human operator on the top? That would be more in line with that Industry 4.0 principle. So how to do that? Therefore, we are going forward with the to-be architecture. And therefore, I have another example, because what do you want if we take that newspaper again from the beginning with that real-time digital overview in the Suez Canal blockage? In the port of Rotterdam, if you go there, when the containers are unloaded, you will see these type of vehicles driving around. So you have this orange rectangular device on wheels. It's fully automatic, so there's no human operator. They just drive around. Fully autonomous. So if this container is unloaded on the truck and the truck drives around and suddenly the car breaks down for whatever reason, then those other cars can automatically decide, ooh, I should not take that route. That will give me a lot of waiting time because there's somebody having a flat tire. I should go the other way around. So these vehicles are actually fully autonomously, and they can... There is a question, but I can't speak Indonesian. My apologies.
I've made it in.
Okay. So that is what I want to... So something like this, we have these cars driving around. It's not my aim to get away of the human operators, but to make it fully autonomously with the idea that they can reschedule their own operations without intervention. That is something that inspires me. So I want something like this, but then on a bigger scale. Because this is only in the port of Rotterdam, and probably in other ports they have something similar as well. I know in the port of Singapore they have something similar. But how to do that on a bigger scale? So if we take a look at at our requirement architecture, the motivation layer, what do we want? These the Industry 4.0 design principles. So now it's time to ask how to build it. So that is the course of actions and the resources that we have to put into place. So we extend this motivation layer with these orange blocks on the bottom. So we will use, so we have to ask ourselves how we will deploy those IoT devices in relation with that current system we just saw. How are we making sure that those computational resources are available to anticipate on those disturbances? Because knowing the disturbance is one thing, but allocating it to the heuristics and algorithms to make a better planning is second thing. So how to make that prescriptive data analytics works, how to make use of simulation, how to exploit on the decentralization and virtualization that is captured here. And finally, how do we have such a service-oriented architecture so that we don't bypass the human, but get it into the loop, so that we rely on both human intelligence, but also the data-driven intelligence provided by the IoT devices. And then we made another model that is on the right. And without I will not explain to you how that model works in all the details. My honestly question to you is, what do you think? What do you think of this other way of modeling? So how smart is the new model? How smart can we make it? Oh, I see that I, wait a sec. I see that I made an error. Nah, that doesn't matter. There is it says here how smart is the as-is situation, but it should be how smart is the to-be architecture, of course. So that is my question to you. So if I, I will quickly skip those. Oh, no, okay, for the sake of time, I will explain. So here you see my reasoning. So how smart is this new situation in modeling? And as you remember from my first story, my issue was actually with that virtualization, the third point, and the decentralization. So can we make the objects decide for themselves? So we try to include that virtualization more by having that big data component actually having not only predictive models to the availability, but also simulation models, the prescriptive analytical toolbox, and operations research techniques like linear programming or maybe reinforcement learning on the edge with machine learning. So can we prescribe what actions should you need to take? Only besides of only having predictions. So we have to extend that big data toolbox. And on the other hand, how to make decentralized decision, then we have to get away that central role of the fleet coordinator and support that with with some software tool that can rely on both the data coming from the logistics agents, and the physical objects themselves, so they can already make decisions on their own. But if they can find it out, they should rely on all the insights made available by that virtualized toolbox on the right, so that to handle those disruptions, so that in the end, together with the fleet coordinator, better results can be there. So this is this was our trial to make logistics smarter, but then the question is it better? And that we can ask you. So I can give you the same question again. And this is my final question to you, by the way. So we have, again, these 6 design principles. Real-time data acquisition, interoperability, virtualization, until service orientation on the bottom. But now we have another model. This is something new. It's not there. This is what we would recommend. And the first point of evaluation is, do people agree? So my question to you is, can you, for another minute, quickly grade how well is this architecture performing on those principles we have made for ourselves? What do you think? And I'm really looking for your honest response. I'm even more happy. I'm even more satisfied if you fully disagree. If you say like you did a terrible job, because then I would say you passed the course because we need critical thinking. So what do you think? I see the first 2 responses coming in. What do you think, Iqbal? Here I see something for the time being. Try to submit, so you don't have to listen to me only. You can also continue filling in the questionnaire, of course. So what I hope, and that is my focus was not on the all criteria, and I see that most of you say, hey, on interoperability you didn't do anything. That's true. That was not our focus. So I'm actually glad that you saw that there is no improvement on the second criterion. So that is a good habit, I would say. You critically check, did you change everything? And the answer is no, because that was also not our focus. And luckily you saw that. Our focus was really on those middle two criteria, virtualization and decentralization. And I see it's slightly higher. It was first around 4, now it's slightly higher. And that, so this way of checking what do we have in mind, do people agree? I just did that with you, but I also did that with other experts in the field, in conferences, with talks, seminars, with like I'm doing now with Iqbal. So this way of asking people to judge how well is this new architecture in comparison with the previous setting, that is already the first step towards validating, evaluating if your model is a good one. So that having being said, that is what you miss in my paper that you have read probably. This exercise I did in other settings as well. So I actually used the same set of questions for different audiences, and that is what you see here. So I try to gather evidence so that I can motivate, why is my model a good one? Why should we implement this? So here you see those design criteria again, those design principles. So the blue bar is the real-time data. The second one is interoperability. So those 6, in the ledger you see those 6 design principles from the Industry 4.0 paradigm coming back again. And then I asked academic experts, how do you grade the baseline architecture? And then you see on average, so this is the 95% confidence interval. So on average, they say, well, the real-time data gathering is quite well okay. It's in between 3 and 4. So that is above 3, slightly positive. But for the others, you see, the interoperability, virtualization, it's way lower. So then they say, it's okay-ish, but it could be improved. And then we ask the same questions, but then with our new enterprise architecture. So that is the target. And then you see that suddenly, on average, the expectations improved. So that you can use to motivate, should we move forward with our architecture? Should we build it? Now we have our first argument, yes, because people think it can be better. So why not? So now you can have the second discussion, does the benefit outweigh the costs? And we did not only ask academic experts, but we also asked people in the field. You see that the confidence intervals are way bigger here, but that's because I only had 7 people from business, while I had, what was it, 30 people from academics or so. And I also asked master students, and there you see that they think the improvement is better, but I think that is because I'm the lecturer and they are afraid of saying that I did a terrible job. But you can see it as a benchmark. I would consider yourself as an expert already on the field as well, because you did the modeling in the courses. So you also have something to say about, is it better? What do you think? And that is what I try to rely on. And that is actually still the question. So how can we use IoT devices for better dynamic planning? So our aim was actually here. The biggest thing we implemented or recommended was the disruption handling system. And that is in the research that I'm doing now, that is what I built. So here you see a more detailed insight into the system that we want to make. I will not discuss that in detail. But the main focus is on that risk management in the middle. So once there is a disruption, we need to ask ourselves, how severe is it? Is it worthwhile to address? Because you might have big disruptions that are easily to take into account, and that's what you see here. So here you have a network of trucks that need to visit particular nodes in the city. Do you wait for big disruptions to occur that are clearly visible, like, yeah, you should do something? Or are you also taking minor disruption that could pile up so that you have some sort of bullwhip effect in your, a butterfly effect in your disruptions? Small disruptions that are not worthwhile resolving on their own, but together they are. And that is more difficult. And that is what I'm actually working on now. So I will close my story with this slide. It's mainly focusing on the video where you see that we are actually building an algorithm that can take these disruptions into account. So we have the network there, then we have our schedule. So that is what you see happening here. We see the road network, Then we have some schedules, so that is what you see now on the top right of the screen. You see all those colors are different routes of vehicles that are passing through all the customer nodes. And then we are just going to disturb it. And by continuing simulating these disruptions, so what we actually said we were going to model in the enterprise architecture, that is what you see here. So this is a simulation tool to see what will happen. And then we use that to learn a prediction model that can help us saying, if this disruption occurs, we already simulated it, so this is the alternative route you should take. And that having been said, I hope that I inspired you that enterprise architecture modeling can help you make systems better and start actually building systems with further research, as I show here. So this simulation model is actually a result from the target architecture that you just graded. Okay? So that's it. Sorry, an hour. I took an hour. Sorry, Iqbal. Oh, I'm so
No
glad
problem.
that
I enjoy your presentation much.
Yeah. Hopefully you didn't fall asleep because you're way closer to the evening than I am. No. Hey, shall I
Yeah.
give the floor back to one of you, Iqbal or Aaron? Because if there are questions, I'm fine to answer.
Yeah. So Aaron, please.
Okay, thank you, Dr. Martin Koot, for delivering such an insightful presentation. So, without further delay, let's move to the Q&A session. For those who wish to ask questions, just raise your hands and turn on camera.
Okay, please, if there is questions, or please ask questions. Yeah, anyway, while waiting for the question, I do have a questions, Martin. So when you come up with the SS architecture, how you come up with those components? Is it based on literature per se, or are you also interviewing people in the company, or
Yeah,
observing
both.
in the
In this particular research that I just presented, I actually had no idea what Internet of Things was back then. So then my first point of contact was, okay, let's see what others have written about this topic. So just to know for sure that I was also on the same page as the fellow researchers in this field. So I started with literature and also not only academic literature, but also company literature, like what companies also provide a lot of insights into their data. So what did they actually provided me to gain insight? What do they already have? But then you still have to verify that with real life companies. And I asked around on the university, hey, do you have some, you are working with DHL or some logistics company. Can you ask them what they use? So then you have actually conversations with real people from the business that can show, yeah, I agree, this is how we do it or not. So it's actually a combination of both. So I would say start with literature just to read yourself in, but always verify if it's really the case in practice. And that is the best way to ask to people who are working on the topics you are investigating.
Yeah, perfect. Yeah, thank you, Martin.
Yeah.
So I actually trying to infuse that approach to my students. So I hope these things that you have done inspires them.
Yeah, there was a question. I saw a hand going up, but now I don't know who it was.
It was Julio, I believe. Julio, do you have questions? So, is there any questions? So let me come to 5, like 1. Otherwise, people that not raising question will not pass the course. So there is this question. There is one question from Rafida, please, Rafida.
Okay, can you hear my voice clearly?
Yeah.
Okay, thank you so much. First of all, I would like to ask Mr. Martin. Perhaps there's a question that I find it interesting is about during the discussion of the further research, for how the my apologies is okay. Okay, so I did see the part where the desirable outcomes that there's a comparison between the experts' evaluation results, which including the academic experts, business practitioners, and the MC students
Yeah, yeah.
about the how you use IoT data for dynamic planning. Personally, as I'm referring you as a researcher, would you lean more the about the research, maybe the solutions? Do you lean more to the business practitioners or the academic experts? That is my question. Thank you.
So if I understand correctly, who should I listen to more? The academic experts or the business or the people in business? Right?
Yes, correct. That is my
Yeah.
question.
Yeah. That is a very good question. Two answers: the official answer and the actual answer. The official answer is the business
You
people.
know what is it? Huh?
They are the ones who have to work with it. If I can't sell it to them, what am I doing then? So in my case, the business practitioners are most important. They are the people who are having the budgets, the investments there. And if you can convince them, then you help them better, and you also help the society. Then it's not only the company that you help in that sense; it's also their customers. So you help people getting better prepared for disruption. So that is then, I would say, in everybody's benefit. But I'm a researcher, so who am I constantly talking to? Other researchers. So who am I trying to sell these points first on, because I need to publish my work, that are the academic experts. So I have to admit, you also see that in the confidence intervals. I had way more discussions with academic peers, other researchers, discussing, is it really true? How did you make that? Where did you get your data from? And that's maybe a good starting point to build a theory first, but it's not directly useful in practice. So in short, business, put focus on business, but yeah, I find it difficult that you start you start with discussing the issues with like-minded, and that is that is in my case the academic experts. But so that is the challenge: how to transfer your knowledge from the university to the outside world. If you can manage that, then you are really having an impact on the world, I would say. But that is difficult. I even have difficulties with that. So, good question. Damn, that was a pain point that you put on the table already for me. So, very well done.
Yeah, perfect. Yeah, but by the way, Martin, since you will be leaving at 4:30, right?
Yeah. Sorry, I'm sorry. I'm terribly sorry for being such an. I'm doing research on planning, but I can't plan myself. So.
No worries. But since that, I think it's better for us to have a group photo first, and then I will continue with my lecture. What do you think?
What you want? I don't mind.
Yeah.
The only thing, yeah, I have another lecture at 10:45 Dutch time, so that is 16:45 in your
Yeah,
case.
like yeah.
And
It-
so what you want? If we can have a discussion, that is completely fine with me. We can also say that you just start your presentation, but then I say thank you and goodbye already beforehand, so that when it's 10:30, that I can secretly leave. But that's what you want. I don't mind.
Yeah. So I think we can or is there any one more questions perhaps from audience? Let's count to three, like 1, 2, 3. Okay, there is
Yeah,
no.
yes,
Oh yeah,
exactly
there's
on
one
three.
question. Yeah, please.
Saved by the bell.
Okay, please, Rama, Atala Rama.
Okay. Good morning, Mr. Koot. Right now I'm just curious about what do you think about the biggest challenges or opportunities for improving the reference architecture you proposed, especially in handling unexpected disruption in real time?
This so you had the biggest challenge in tackling the issues that they have currently, or the biggest challenge for my the model that I make?
The biggest challenge in the model that you made, and how about how can you imagine about the biggest challenges in the future?
Oh, yeah, nah, maybe I already have a challenge that I'm actually addressing now. Here you see this model that I just show, and maybe I can fast forward the video a little bit to see the more interesting part with the disruptions. I'm actually having that, this research is now in the publication process, but I have a discussion with fellow academics again, I have to admit, on the scalability. So what I actually did, I trained a neural network in this case. So I made a simulation model to simulate what could happen if we reschedule, and I did it a lot. Then I had to train a neural network, which also is quite some computational power, for only one task. So the only task is, once there is the disturbance, what should we do? So that is the challenge. It requires so many efforts in calculating because there's so much stuff that can go wrong, that when you have to scale this up to a company level, the benefit is that once you have the model trained, you can directly implement it. Then it's there. Then it's like, oh, something unexpected happened. What should we do according to the model? So that is good. But the disadvantage is there's a lot of training and simulation going beforehand. And how do you ensure that you have taken into account everything? Because that is the difficulty. You don't know the unknown. So I try to address that. I just said, whatever can go wrong, we try to simulate. So I even don't talk in disturbances. I just say, there is a disturbance somewhere in the network that is affecting that part with a particular severity. So more traffic times, or a vehicle that so that's it. That could be that there is a vehicle breaking down, or it could be that there is a traffic jam, but that I'm not going into that level. I'm just looking at the consequences. Assume this is the delay. How could we have prevented that? Do you then have all the possible delays simulated? Probably still not. So probably you have simulated 100 scenarios, and then another one that you haven't thought of before is actually happening in real life. And that is the challenge. So how to scale it up, how to make sure that you have simulated all possible outcomes to prevent yourself, to learn what to do when something unexpected happens, and how to build that for each individual company. That is the challenge, because it's quite a lot of training time. And that is so in the reasons that I try to publish, we show it works, but it requires a lot of effort before actually making it. And that is also then for another case, because now I've only had one company. If you had another company, they also need quite some training still. So that is the difficulty. It's not a model you can generalize very easily yet. Yeah, so I don't have an answer how to fix that. It's just something we run into. So good question as well. And I believe that applies to all things. Oh, sorry, I saw that you were muting yourself. Sorry, I'll wait for you.
It's all good. It's all good, sir. It's interesting how you really handle the problem right now, and it's really, really inspired me to do so.
Nah, that's good. But also know that doing research is actually a road of challenges. So once you have found something that works, you probably have 2 new problems arising, which is good because you can investigate that. So for yourself, it's always nice, but it's always a challenging road, which makes it an interesting field, because it's, I really love engineering.
Okay, that's perfect. I think we can close the Q&A sessions because it's approaching of 9:30. And I will hand this to Aaron for the group photo. So please, Aaron.
Okay, I kindly ask all participants to turn on their cameras as we capture this moment together. So everyone, please turn on your camera so we can get the photo. I'll wait 1 minute from now.
And by the way, oh man, I'm having something in my throat. Sorry, my voice is going weirder and weirder every minute I start talking. But if you have questions and have probably either you can easily contact Iqbal because Iqbal and I are having each other's phone numbers, so we very quickly get in touch with each other. Or all my information is also available online, so you can also send me an email, something like that. So if you really have a question like, hey, how did you do that, or what is your perspective, let me know. I'm open to help you with that. But let's make the photo first. I like that.
Okay. I'm going to count to 3. Okay. 1, 2, 3. Smile.
Yay!
Okay. Once more. 1, 2, 3. Smile. Okay. Thank you, Dr. Martin Koot, for the time. We had a great time together. So unfortunately, the time has come. So we have to move to the next agenda. Thank you, Dr. Martin Koot.
Yeah, terima kasih. Hopefully my Indonesian is not that rusty. But I really liked the session and hey, sorry Iqbal that I couldn't. I will stay around. I will listen to your first talk, but then at 10:30, then I will secretly leave the meeting if you don't mind. Then
Yeah, no problem. But I think I will try to, present as brief as possible of my research. So let me try to finish that before you leave. Because
Yeah,
in this
okay. And
event,
otherwise,
this is your main stage. But I think Aaron, I will start directly. So I will just to give the students a perspective of how the logic of reference architecture can be applied for basic research, but basically a little bit different than what they have learned in the course. So this is actually, so I will tell you a story of my recent submitted paper. So currently under review in IT for Development journal, this journal from Taylor and Francis. So it's entitled Designing a Reference Architecture for Developing Smart Rural Communities. So this is the brief of the motivation that in 2030, most of people in developing countries, while be living in urban, a large portion of them still living in rural areas, right? And this is very relevant to Indonesia. So I will briefly explaining this, that people in rural have, these difficulties, high poverty rate, lack of productive talent, and they trap in poverty. This is one of the slides for my defense, actually. So, and how to improve their welfare is by intensifying the use of IT, right? So for improving their economy, their well-being, their healthcare, etc. So this intensification of IT use, we call this in general as smart rural communities, or smart rural or smart village, or whatever you want to call it. Yeah. So, and what are the issues here? So the issues that we try to come forward is that we want to bring guidelines for developing such smart rurals, right? And what are the studies have been done in this area in providing guidelines is that they are domain specific, only in healthcare, only in economy, etc., or only discussing single abstraction layers, like only discussing the technical part, only discussing the strategical part, only discussing the business part, etc. Some of them, yes, already discussing multiple domains and abstraction layers, but there is still gaps. You know, we are researchers. Our hobby is to finding the gaps in such a way we can still get our paper published, right? So the gap is that yeah, the study that have discussed multiple domain and abstraction layer are not aligned with motivational components, and they are not clear on defining how the relationship between technical application and business component relate to each others. So this is the gaps that we're highlighting. And this is our methodology. So we combining systematic literature review to derive the reference architecture and validating them by focus group discussion. So similar with what Martin have done with the architecture, right? Yeah, but this one is still in the early stage of the research. So from about 400 articles, we come up with 55 articles. And what we did to the article is that we try to identify these components. So we come up with this meta model of motivation view. So we define this based on Archimate, how we can come up with capabilities. So basically what we are trying to do is that what are the capabilities required, what are the smart rural capabilities required to address the problems in rural areas, so to speak, and how we can realize these capabilities. So those are the motivations. So we come up with this meta model, and based on this meta model, we extract the content of the articles. Yeah. So we try to understand, we try to identify what are the drivers of developing smart rural communities, what are the problems there, and how to address the problems, and then how the technology can support addressing these problems. Okay, so basically we identifying this component from the articles based on meta model of these Archimedes views. So this how systematically, this how enterprise architectures play a role in my research. So, and these are the results. Yeah. So you can see there are many components here. The number here indicates article supporting the component, and long story short, we come up with this nice, with this better picture, right? So basically, so just pray for me, audience, students, that this paper published, so you can read them and get the insight of this paper after it published. So we come up with this story that we need these capabilities, right? Tourism, economy, environmental, mobility, e-government, etc. And then these are the business functions, application components, and technology components required to realize those capabilities, so to speak. I will not go into the detail, but the idea is that for, let's say, this smart healthcare management capabilities to be realized, we need to, let's say, having this healthcare management functionality in place for diagnostic, health monitoring, and emergency response. And for that business function to be supported, we need these application components, like we need telemedicines, we need health monitoring systems, and we need emergency and alert systems, right? And these are components enabling those applications. We need mobile devices, we need web servers, we need IoT device, wearable devices, something on your wrist, etc. Right? So these actually components that we derive from the literature, and basically this component is used as a means for the government to develop smart rural communities. So this can be its starting point. So the starting point, yeah. So in this case, I will show you that this can be applied in West Java. So in West Java, there is these programs of smart rurals in different areas, including commerce, agriculture, fishery, etc. And we mapped the component that has been implemented according to these types of smart rural in West Java. And we found that the component implemented in West Java Rural Digital Initiative is basically compatible with our reference architecture, meaning the component of our reference architecture can be picked to the case study. Yeah. Okay. In other way, the component. So I think what in screen is different with what I'm showing in my screen.
We see your synthesis or difficult word, synthesis. No, synthesis. In Dutch, I would say synthese, but I don't know how to pronounce the isis. But we see the motivation view still. I believe Iqbal is really frozen. Uh-oh. Aaron?
Yeah. Wait. Mr. Iqbal still rejoining the meeting. Please wait. That's from my side.
I was quite impressed by the introduction video they showed, by the way, when we were starting this session. So maybe I should have something on the side. Oh, there he is already again.
Actually, I have trouble with my connection. But anyway, you have seen, right, in the slides that I have shown earlier, how we use the enterprise architecture logic. Basically, we use enterprise architecture modeling of Archimate, and we derive the components from the literature and come up with an architecture. So the content is in my computer. I'm using the other one. So the idea is from the literature, we come up with the component, and then the component is used as the starting point for developing smart rural communities. Right? And for the validation, we use the case study in West Java. They have developed smart rural initiative in the area of economy, agriculture, healthcare, and so on. And we found that our component is useful. I mean, our component is compatible with what they have implemented in place. So that's how the validation works. So I think that's my presentation. So I'm sorry with the error. I have a new MacBook, by the way, but it still has a problem with it.
I would, if I may ask what I consider it's also coming. It's a little bit related to the question that the first student asked after my session. What I would I actually think it's a good habit that you structure in a very good manner. Like this is what you have to do by means of enterprise architecture modeling. So use those elements to screen the literature that you have found. I would consider it a very insightful way of seeing what others have done on the topic. So since you are an expert on rural smartness, did that exercise already provided you new insights that you were that surprised you? What did you did you find something that you were like, hey, wait, didn't expect that?
Hello, Martin. I'm back.
Oh yeah. Oh yeah. Okay.
Yeah. So I think that's my presentation. So let me show a little bit where I left off. So yeah, after this one, we come up with this more detailed architecture where we derive business component, application, and technology, and how they interrelate to realize the smart rural communities. And then we validate those components to the case study in West Java Digital Village program. And long story short, we found that the components are, let's say, compatible with the real case study.
Cool.
Yeah. So this is what the paper is about. So please pray for us such that this draft is published.
I will pray for myself as well because I want to read it. So the sooner it becomes published, the quicker I can get access to the results. So that sounds really cool.
Yeah, fingers crossed.
Yeah, I hope so. Now I wish you all the best. Hey, given the time, I see that already running a little bit too late. Hey, so,
Yeah.
really, thanks for hosting the session, and my apologies for leaving in such a short manner, but I really liked it. So if we have if we can do it once more, you can count me in.
Yeah, of course. I think for the next session, I think we can come up with a new research. Perhaps we can do something together and present it to the audience.
Even better. So if students also want to be involved in the research, let's Iqbal know. Maybe we can make something better out of this as a start. So that's
yeah, of course. Yeah. By the way, I'm currently involved in this laboratory of system architecture and governance. Like the how you call it? It's not the head. Like, yeah, you lead the lab basically.
you're one of the big guys now.
No, not really, no, of course not. But yeah, we want to, I mean, elaborate some research topic here related to this enterprise architecture stuff. Yeah, but anyway, thank you, Martin, for catching up with us. So I really appreciate it. I really missing you and SKD and the UT, and you know the spring there, the spring ambience at the UT. So yeah, thanks a lot.
Yeah, thank you as well. And it's always good to catch up. So let's do this more often. So let's definitely find something to investigate on ourselves. Then maybe we can either meet each other in Enschede or in Bandung.
Yeah, of course. Yeah, perhaps. Yeah. I will keep in contact with you. Yeah.
Yeah. Hey, thanks. Hey, if you don't mind, I really have to go because I have
Yeah,
7
okay.
minutes to run to
Thanks a
the
lot.
other building. Hey, good luck, students, and thanks for the participation.
Yeah. Bye-bye.
Bye-bye.
Doei.
Thanks, Aaron, for hosting.
Yeah. So go back to Aaron for the closing and the absences.
Okay. Thank you to our esteemed speakers for the insightful presentations. And a big thank you to all participants for joining today's session. That concludes our event. So the present will send in the chat columns. For the link, it's in the chat column, so you can access it. If there's any problem with the link, please let me know. Okay, I'll wait till 4:40 p.m. Okay. That concludes our event, and we appreciate your time and engagement. See you in the next session, and goodbye.
Okay, thank you, Aaron. Thank you all. Bye.